moving on to example 5. Alright, so let's see, another way of writing this. We could take the sine of both sides of our function. Alright, and okay, there we go. So then we end up with sine y equals sine of arcsine of x is just x. So now if I take the derivative of both sides, right, derivative of sine of x, derivative of f of x, just x, sorry. Derivative of sine sine y is cosine y. Derivative of y is dy dx. We have to use the chain rule there. Derivative of x is just 1. Alright, and then so we get dy dx equals 1 over cosine y. Oops, 1 over cosine y. And we know that as secant of y. Okay, so this is okay. The derivative is secant of y, but it's kind of hard to use that. We usually have it in terms of x. So we have to figure out a way to write secant of x secant of y in terms of x. So this is something that we did do a tiny bit last year, maybe a bit in the beginning of this year. Alright, so if we go back to our original function, y equals arcsine of x. So this is asking, at what angle, right? This is our angle. At what angle is this ratio? Arcsine of x. So we're asking, where is the sine of x equal to this ratio? At what angle is the sine of x equal to this ratio? Alright, so we can figure this out. Just draw a quick sketch here of a triangle. If we let our angle be y, sine, remember SOHCAHTOA, opposite over hypotenuse. So x, well, we could write that as x over 1. Now it looks more like a ratio. Sine is opposite over hypotenuse. We are looking for secant of y. Secant, remember, is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So secant is going to be hypotenuse over adjacent. Well, we don't have the adjacent side yet, but we can find it. Alright, a squared plus x squared equals 1 squared. Solving this, alright, we're going to get the square root, and I'm just going to write it over here, square root of 1 minus x squared. Now we can tell the secant of y is adjacent over hypotenuse, which is just square root of 1 minus x squared. Alright, so what we just figured out now, sorry, I made a mistake there. It's hypotenuse over that, so it's 1 over square root of 1 minus x squared. Okay, we just figured out that the derivative of inverse sine is 1 over the square root of 1 minus x squared. So now we have 6 more derivatives that you just need to remember. Make flashcards, quiz each other, alright? Practice them. That's the only way that you're going to be able to use these. Now again, you can derive all of them if you want, but that's a lot of time. If you just take the time to memorize these, then it might be a little bit easier. Alright, so let's try another example. Find the equation of the tangent line. Tangent means derivative. We were talking about the derivative of this. Alright, so we're going to need to find the point for the equation, so I guess I'll do that first. So y of 1 equals inverse cotangent of 1. And that's asking at what angle is the cotangent 1? And we could think about that. That would be like 1 over 1. So we're really asking at what angle is tangent equal to 1. and we have that at pi over 4, right? Because that's square root of 2 over 2, square root of 2 over 2. So the tangent is 1. Oh, that should be a 4, at pi over 4. Alright, so we figured out a point 1 pi over 4. Now all we need for our equation is the slope. So we have to do the derivative. So the derivative of inverse cotangent, or arc cotangent, is negative 1 over 1 plus x squared. And we're going to evaluate that. We're looking for the value of the derivative at 1. So plug in 1, and it looks like we get negative 1 over 1 plus 1 is 2. So we just put that together, write our equation. So y equals 1/4 pi minus 1/2 times x minus 1. Okay, let's keep going. So we have a couple here. We just need to differentiate, and you really just need to know the derivatives of these functions. Now look here, we have a chain rule application in this problem. So we take the derivative of this. The first part's easy, it's just 4. Alright, now it's going to take a little bit of time, so we know that this is 1 over square root of 1 minus, now in ours we had x squared, but it's not x in this case, so we just have to write 2x squared. Remember, think of it just as one blob there, alright, squared, times the derivative of our inside function, which was 4x, and here we just want to rewrite it a little bit, so it looks a little bit nicer. Alright, 4x over, simplify that inside part, 1 minus 4x to the 4th. Alright, moving on to the next one. Looks like we're going to have a product rule here. And then on this part, the arctan part, arctan, we have x to the 1/2 power. Alright, so we have the first function times the derivative of the second. The derivative of arctan is 1 over 1 plus square root of x, and we don't have x this time, we have square root of x squared. Now because we didn't just have x, we had the square root of x, we also have to multiply that by the derivative of the square root of x, or x to the 1/2. So that would be 1/2 x to the negative 1/2. Remember, subtract 1 from your exponent. Alright, so we have here x to the first, oh wait, I'm not done, am I? I forgot the product rule the other side. So the first times the derivative of the second plus the second function times the derivative of the first. So I just have this arctan square root of x. Okay, not too bad. And we just need to clean this up. So we have x to the first, x to the negative 1/2. We can put that together as x to the 1/2. Instead of writing 1/2 times this function, I'm just going to put the 2 in the denominator. And we have 1 plus square root of x squared would just be x. And if you really want, you could rewrite this as square root of x over, and you could multiply that out, 2 plus 2x, or just leave it factored. Alright, we have one more problem, and I'm going to just start it down here just so I have a little bit more space. Alright, this is definitely a case where we're going to have to use the chain rule. We have 1, 2, 3 functions. Alright, that 1/5, we can just throw it in the front. It's just a constant. Okay, instead of dividing by 5, I just write it as 1/5. So now we just need to take the derivative of our arcsecant of sine of 3x. Alright, arcsecant, the derivative of arcsecant is 1 over, and we have the absolute value of x, but we don't have an x, we have sine of 3x. Okay, times the square root of, instead of x, we're writing sine of 3x, and that would be squared, and I believe it's minus 1 on the inside. Alright, because this is the chain rule, we just took the derivative of the secant function. But we still have more to go because we had a function inside a function inside a function. So the derivative of sine of 3x is cosine of 3x. And then we had a derivative inside a function inside the sine function, which is 3x, so the derivative of 3x would just be 3. And we can combine this together, make it look a little nicer if we want. Alright, 3/5 times cosine of 3x over our denominator, absolute value of sine of 3x, times the square root of, I'm just going to write this a little bit differently, sine squared of 3x minus 1. And close my parenthesis. And there we go. So I think I'll try one more example. We have enough time for that. Alright, differentiate that function to a single term. Alright, so we have y prime, let's start with that. It's the easy part. Equals the derivative of arc sine of x is just 1 over square root of 1 minus x squared plus, alright, this part we have, alright, I'm going to write this over here so I don't mess up, 1 minus x squared. Another way of writing that is 1 minus x squared to the 1/2 power. Alright, so we have the first function times the derivative of the second function. 1 minus x squared to the negative 1/2 times the derivative of the inside, which is negative 2x. Okay, plus the second times the derivative of the first. Alright, it's definitely not a single term yet, but maybe we can simplify that middle part a little bit and it'll look a little nicer. So we have 1 over square root of 1 minus x squared plus, alright, 2 over 2, that gives us 1. We have a negative, so I'm going to change that plus to a minus. So ignore that that's right there. Alright, this is to the negative 1/2 power, so that's going on the bottom, and we have x times x, so that's x squared. So we have the square root of 1 minus x squared on the denominator. Alright, and our last part is square root of 1 minus x squared. So in order to combine these into a single term, we're going to have to multiply to get our common denominator. So we're going to have to multiply by 1 minus square root of 1 minus x squared over square root of 1 minus x squared. In the numerator, when you multiply that, you simply end up with 1 minus x squared. Alright, so to skip one step, just for time, and maybe my writing on this computer, I'm going to combine it all at once. 1 minus x squared plus 1 minus x squared. Alright, combining that, it looks like I'm going to get 2 minus 2x squared over the square root of 1 minus x squared. Technically we had a single term here, but we can make it look a little bit nicer. If you want, you can multiply again by this. So we would get that out of the denominator. That's up to you. Or you can leave it just how it is. Alright, an alternate form. If you did multiply, to rationalize it, I believe it would simplify to 2 times the square root of 1 minus x squared. I don't know. You let me know. Keep looking on the website for the next video.